Imagine a traveler, not across continents but between stars. For millennia, it has drifted through the cold dark void of interstellar space, carrying secrets from a distant solar system. This traveler is Comet 3 I/Atlas, only the third interstellar object ever confirmed to visit our solar system. Its arrival is a rare chance to study a piece of another star system up close. Unlike most comets born in our own Oort cloud, 3 I/Atlas's path and speed reveal it's not from here. Ejected from its home system long ago, it now races toward a close encounter with our Sun in October 2025. As it nears the Sun, the frozen gases and dust within will erupt, transforming it from a dark rock into a glowing spectacle with a brilliant tail. This transformation is both beautiful and scientifically invaluable, revealing the composition of a world born around another star. 3 I/Atlas follows in the footsteps of Oumuamua and Borisov, each a clue in the puzzle of planetary formation across the galaxy. Are interstellar comets common? Are they like our own? These are the questions that drive us. As 3 I/Atlas approaches, astronomers and skywatchers alike are preparing for a cosmic show. We await the secrets this celestial wanderer will reveal as it dances with our Sun. Its visit reminds us that our solar system is not an island, but part of a vast, interconnected cosmos. The story of 3 I/Atlas is just beginning. For millions of years, 3 I/Atlas has been alone in the void, preserved in the deep freeze of interstellar space. Its ices, water, carbon dioxide, methane, are relics from a protoplanetary disk we've never seen. But now, its journey is ending as it's drawn in by our Sun's gravity. It plunges inward past Neptune, Uranus and Saturn, still unchanged in the distant cold. Crossing Jupiter's orbit, the Sun's energy begins to stir the comet, warming its surface for the first time in eons. As it nears Mars, the Sun becomes a powerful furnace, rapidly raising the comet's temperature. The energy penetrates its crust, awakening ancient ices buried below. The silent traveler is about to find its voice, speaking in gas and dust. This journey from deep freeze to solar warmth is a story of dramatic change. The comet transitions from inert rock to a dynamic, active world. Every kilometer closer to the Sun accelerates this transformation. We witness the end of its lonely voyage and the start of a spectacular, fiery dance in our solar system. 3 I/Atlas's story is one of change, wonder, and cosmic connection. When an object frozen for millions of years is suddenly heated, it undergoes sublimation, solid ice turning directly into gas. This is what's happening to 3 I/Atlas as it nears the Sun. Ancient ices erupt into space as jets, bypassing the liquid phase entirely. These powerful jets blast gas and dust into space, forming a glowing coma around the nucleus. The coma, sometimes larger than a planet, is the first visible sign that the comet is waking up. Sunlight excites the gases, making them glow in vibrant colors. Green from diatomic carbon, blue from ionized carbon monoxide. As 3 I/Atlas approaches perihelion, jets intensify, the coma grows, and the comet becomes a spectacular sight. We watch a world tear itself apart, shedding material it carried across interstellar space. It's a destructive yet creative process, giving birth to one of the night sky's most beautiful sights, a comet's tail. The awakening of 3 I/Atlas is a cosmic event unfolding before our eyes. Every active comet, including 3 I/Atlas, has two tails, each telling a different story. The dust tail, made of solid particles, is pushed away by sunlight, forming a broad, curved trail that marks the comet's journey. The ion tail, made of charged gases, is swept straight away from the Sun by the solar wind, glowing blue or green. The dust tail lags behind, tracing the comet's path, while the ion tail points directly away from the Sun. These tails reveal the forces at play: sunlight, solar wind, and the comet's own volatile materials. Watching 3 I/Atlas, you may see both tails, a broad whitish dust tail and a long, straight bluish ion tail. Their shapes and colors are clues to the comet's composition and the environment it's passing through. The interplay of these forces creates a dynamic, ever-changing spectacle in the sky. 3 I/Atlas's tails are more than beautiful. They're a living record of its journey and the Sun's influence. Each tail is a chapter in the story of our solar system's connection to the wider galaxy. To appreciate 3 I/Atlas's journey, zoom out to the grand stage of our solar system. The Sun is the spotlight, with planets tracing their familiar orbits. Enter 3I/Atlas on a dramatic sweeping hyperbolic path, just passing through. In October 2025 it will reach perihelion just inside Mars's orbit, while Earth watches from across the Sun. We'll see its glowing tails sweep through the constellations, a temporary guest in the planetary dance. Its steep trajectory lets us observe how the solar environment changes with distance. As it moves from Mars's orbit to perihelion and back out, we can track its brightness, gas production, and tail shape. Telescopes on Earth and in space will follow its every move, capturing a natural experiment on a cosmic scale. This event connects us to the wider universe, reminding us that our solar system is part of a much larger story. 3I/Atlas's passage is a rare, shared moment in our cosmic neighborhood. Let's imagine standing on the surface of 3I/Atlas. The landscape is dark, rugged, and covered in cosmic dust, insulating ancient ices below. Craters, cliffs, and fissures mark a world shaped by thermal stress and eruptions. Jets of gas and dust burst from sunlit cracks, sending plumes sparkling into the black sky. These eruptions can even cause the nucleus to tumble and rotate. The dust and debris scattered across the surface hold clues to the comet's origins. Are they like our own, or truly alien? While we can't land on 3I/Atlas, telescopes can analyze its light, revealing color, composition, and active regions. Each observation transforms this distant point of light into a tangible place, a piece of another solar system. Studying 3I/Atlas up close, even from afar, is a rare scientific privilege. To understand 3I/Atlas, we compare it to comets like Halley and Hale-Bopp, familiar members of our solar system. Halley's regular returns taught us comets are predictable, while Hale-Bopp's brilliance showed the beauty of a pristine comet. 3I/Atlas, a one-time visitor, is even more precious. Its predecessors, Borisov and Oumuamua, were our first glimpses of interstellar objects. Borisov behaved like a familiar comet, suggesting planetary building blocks may be universal. Oumuamua was mysterious, showing no cometary activity and sparking debate. 3I/Atlas is our crucial third data point. Will it be familiar or reveal something new? Each interstellar visitor helps us build a broader understanding of the cosmos. 3I/Atlas is the next chapter in this unfolding story. 3I/Atlas's encounter with the Sun will be brief. After October 2025 it will be flung back into interstellar space, never to return. We have only a short window to study it, making every observation invaluable. Its legacy will be the data it leaves behind. Chemical fingerprints in its gases, clues in its dust. Spectrographs will reveal its composition: water, carbon monoxide, organics, a recipe for planets from another star. Comparing these findings to our own comets tells us about the galaxy's chemical diversity. Dust analysis will reveal the physical conditions of its home system, and isotopic ratios may trace its origins. This single flyby will fuel research and debate for years. 3I/Atlas is more than a beautiful sight. It's a scientific treasure chest from across the galaxy. Its visit is temporary, but its impact on our understanding will be lasting. The comet's fleeting presence will echo in science for generations. The arrival of 3I/Atlas forces us to reflect on our place in the universe. For most of history we saw the sky as familiar and predictable. Interstellar objects shatter that illusion, proving our solar system is part of a vast galactic ecosystem. 3I/Atlas is a messenger from another world, connecting us to a distant creation story. Studying its composition asks a profound question: are the ingredients for life common across the galaxy? If 3I/Atlas is rich in water and organics, it strengthens the idea that life could arise elsewhere. Each interstellar visitor is a clue in our search for life beyond Earth. As we watch 3I/Atlas's brief fiery dance, we connect with the wider universe. We see a piece of another world and learn more about our own. It's a moment of wonder, discovery, and perspective, reminding us that we are part of a dynamic, interconnected cosmos.